sequences and series. And we have been talking so far about sequences, and we've done 3 different types: arithmetic, geometric, and in the last lesson, quadratic sequences. We're now going to talk about series. And series are when we add up the terms of a sequence. So for example, here we've got an arithmetic sequence, 2, 5, 8, 11, common difference of 3. The corresponding series would be 2 plus 5 plus 8 plus 11, right? And just as we had Tn representing the nth term, Sn represents the sum of n terms. So in this example above, for example, the sum of 3, S3 means the sum of the first 3 terms. 2 plus 5 plus 8, all right, comes to 15. Now, we need to be able to calculate the sum for arithmetic series and geometric series, but not for quadratic series. We're going to start off with deriving a formula for Sn for arithmetic series, and it's kind of a famous story that Carl Gauss, a very famous mathematician, he and his dad and his uncle were trying to see who could add up the numbers on a dartboard. In other words, 1 plus 2 plus 3 up to 20, who could add them up first. And he got the answer in his head before either of them. And he was a young boy, and they asked him, how did you do that? He said, well, what he had done is he had pictured the numbers, right? 1 plus 2 plus 3, the whole way up to 20. And then in his head, he had pictured them going the other way, 20 plus 19 plus 18, the whole way down to 1 underneath, right? Then what he did is he said that he had added the 2 rows, and we get 21, and we get 21, and we get 21, right through to 21. So what he ends up with 20 lots of 21, right? And 20 lots of 21, actually 420, right? Quite easy to do that in one's head, actually, because if we multiply the 10 in afterwards, in other words, we just go 2 times 21, we get 42, and then multiply the 10, which is part of the 20, to get 420. Now that number needs to be halved. And the reason it needs to be halved is because the numbers were written down twice. We had the purple numbers and the green numbers. So in fact, the final answer is just 210. If we add up all the numbers on the dartboard from 1 to 20, we get a final answer of 210. And he did this as a young boy. There's various different stories about how old he was. Some people said he was 6 or 7, but quite an extraordinary feat in his head. The method that he used is exactly the same method that we are going to use, right, to generate a general formula. Now, this method will work for any arithmetic sequences, as we always get equal sums. And the question why is, well, because the top row grows by the same amount as the bottom row reduces. So let's just take another very simple little example. Suppose we wanted to add the numbers 2 plus 5 plus 8 plus 11. If we wrote them down underneath, 11 plus 8 plus 5 plus 2, I think we can see what's happening here. From here to here, this one's growing by 3, but this one's growing by 3 and this one's shrinking by 3. Each of these adds up to 13. So for this particular one, we've got 4 lots of 13. But then what we would need to do is we need to halve it. And the reason we're halving it is because we've actually included the numbers twice. So we get a final answer here of 26. Okay, let's now look at the actual formal proof, which needs to be learned for tests and exams, right? The sum of n terms of an arithmetic sequence, the first term is just a, The next term, remember, we add d to get our second term. To get our third term, we add another d. So the third term will in fact be a plus 2d. All right. And this actually carries on the whole way along. You might remember that our formula for the nth term, our kind of last term, is n minus 1 lots of d. Right, so that's Tn, actually. That's our normal Tn formula. So T1, T2, T3, up to Tn. When we add them all up, we get Sn. Underneath here now, I'm going to write them down backwards, exactly like Carl Gauss did. So what I'm going to get here is I'm going to get A plus n minus 1 lots of d. This is the last one. This is this one over here. All right, etc. Okay, and this will in fact go the whole way down to A, which is the first one when I write them down backwards. Now, when I add these two rows up, I'm going to get Sn plus Sn. I'm going to get 2 lots of Sn. This is going to be A plus n minus 1d. It's actually going to be 2A plus n minus 1 lots of d. Right? And this is going to happen n times, right? Because we've got n terms, and each of them will result in the sum of 2a plus n minus 1 lots of d, right? So I can shorten the right-hand side by writing it as n times 2a plus n minus 1 lots of d, all right? And lastly, I don't want twice Sn, I just want the sum of n terms. So the last thing I'm going to do, and we did it in the numerical examples as well, is I'm going to divide through by 2 on both sides, and I get 2a plus n minus 1 lots of d multiplying by n over 2. And this formula is crucially important. It's our formula that we get supplied in tests and exams. All right, there it is. And we need to be comfortable with using it. All right, we need to be able to derive it as we've just done above here. It can also be written in a slightly different form. If we split these two A's into those two A's, if we split them into A plus A, then we get this formula. We get n over 2, A plus. Now this piece over here is actually our nth term, right? This version of the formula is not given, right? What it basically says is n over 2, first term plus last term, right? So just to show you how that would work, remember when Gauss was trying to add up the sum of 20 terms, all right, it's 1 plus 2 plus up to 20, all right? What this formula says is you can just take the number of terms divided by 2 and then multiply that by the first term plus the last term. Right, and what you see we get is 21 inside the bracket, and we get 10 outside the bracket, and we get the same answer that Gauss got, which is 210. Okay, this version is not supplied, this version is supplied. Let's try using it now. Right, so first question. Find the sum of 30 terms of this arithmetic sequence. Right, I'm going to write the formula down. Sn is n over 2, 2 lots of A, plus n minus 1 lots of d. That's our formula as we get provided it. So the sum of 30 terms is going to be 30 over 2, 2 lots of A happens to be 3, so it'll be 6. Sorry, well, it's 2 times 3. This is going to be n minus 1, n is 30, so it'll be 29 lots of d. And remember, d is found by taking any term minus the term before it. D is actually 4. All right, we can slot all of that into a calculator, and we will get our kind of final answer here, that the sum of 30 terms is actually just 1,830. Right, let's do a slightly different one. This is actually asking how many terms, all right, must we take of this series to achieve a sum of 345. I'm going to write the formula down again. Always good practice to do that. Notice I'm not using the term formula. I'm using the sum formula. This is all about the sum. The formula looks like this. Okay, and what we're going to do is we're going to put the answer here, 345, is n over 2, 2 lots of A, n minus 1 lots of D, right? And D in this one is 3. I'm going to write that 3 over there. It's just easier to multiply it in like that. Right, what we've now got, okay, we're going to multiply both sides by 2. We get 690. So we get 690 is n 4 plus 3n minus 3. This is 690 equals n into 3n plus 1. Right? I'm going to multiply out that bracket and I'm going to subtract the 690. I end up with 3n squared plus n minus 690 equals 0. Right, now I could either use my quadratic formula, right, or I could try and factorize it. This one actually does factorize to 3n plus 46 n minus 15 equals 0. Right, now here I'm going to get n equals negative 46 over 3. That's not possible. Right? N has to be a natural number from 1, whole numbers from 1, including 1, upwards. All right? So it's not possible. That's clearly not the answer. Or n equals 15. And so the final answer is that actually 15 terms will give me the sum of 345. Okay, this next one, all right, we could... we're not sure how many terms there are here, all right? But in fact, what we might see if we're observant, all right, is that these are just the multiples of 3. And in fact, this is the 100th multiple of 3. So we actually know that we've got 100 terms here. If we didn't know that, all right, we could use our term formula and solve for n to get 100, right? This particular example, I could use either of the two formulas I get given. Remember the standard formula, the one that, I only get given one of them. This is the one I get given, n over 2, 2 lots of A plus n minus 1 lots of D, right? I could use that one, or on this occasion, I could actually use, because I know the first term and the last term, and I know how many there are, I could use this one, n over 2, A plus Tn. Right, so in fact it's going to be 100 over 2. The first term is 3. Right, and the last term is 300. And when I put all of that into a calculator, I get the final answer of 15,150. Okay. Right, this next one, again, I could use the sort of quick formula, or I could use the standard one that I've been given. I could use the first plus last, because I know that there are 26 terms. In fact, let's do that. The sum of 26 terms here is going to be 26 over 2. A is the first term, plus Tn, the last term. Right, and here I get a final answer of 455. Okay, question number 5. Determine this sum. All right, now this one, we don't know necessarily how many terms we've got. All right, so let's start off by using this formula. It's definitely arithmetic, so let's start off by using this formula, A plus n minus 1 lots of D. We know that the nth term is 2. We know that A is 50. And we know that D is, in fact, negative 4. Now, there's only one variable left in here, and that is n. Let's see if we can solve for it. We're going to subtract 50 from both sides. We get minus 4 lots of n minus 1. We've got choices now. We can either multiply this negative 4n All right, or it's actually easier just to divide both sides by -4 at this stage, and we get 12 equals n minus 1. And now add 1 to both sides gives n equals 13. We haven't got the answer yet. We haven't added up the terms. What we have got is how many terms there are. Remember our formula? Sn is n over 2, 2 lots of A, plus n minus 1 lots of D. Right. N is 13. A is 50. So it's going to be n minus 1 will be 12, and D is minus 4. Again, we can go to our calculator, put all of that in, and we get 338 as our answer. Right, that is finding sums of arithmetic sequences. What we're going to do next is we're going to find the formula for the sum of terms of a geometric sequence. Right, now remember, so I'm going to write down Sn. My first term is A. My next term is A times R. This is a geometric sequence. The next one is A times R squared. Right along to the nth one, and we'll remember the formula is A times R to the n minus 1. Right. Clever trick now. What we're going to do, we're going to multiply this equation by R. So A times R becomes AR, and I'm going to write that over there. This term over here, AR, becomes AR squared, and I'm going to write it over there. The one before over here will become, the one that was AR to the n minus 2 will become AR to the n minus 1. And this one, when I multiply it by R, remember I'm going to add my exponent, and I've got an exponent of 1 on the R, I'm just going to get AR to the n. Okay. Now what I'm going to do is I'm going to subtract these two equations, right? I'm actually going to subtract the bottom one from the top. So I'm going to go Sn minus R lots of Sn, okay? I'm going to get an A. I'm not going to get this term because these are going to cross out. These are going to cross out. All of them are going to cross out, but I'm going to get a minus AR to the n, okay? And remember, I'm trying to find Sn. So what I'm going to do now is I'm going to take Sn out as a common factor. That moves it from being in two different places to in one place. I'm also going to take out an A on this side, and I get 1 minus R to the power of n. And lastly, I'm going to divide both sides by 1 minus R. So I get A, 1 minus R to the n over 1 minus R. All right. And so here we have a formula, all right, which gets provided in tests and exams. It's really important to note that in this formula, R is not allowed to equal 1. Okay, so we can't use it when R equals 1. That's not really a big problem. If I was adding up this sequence, which has a common ratio of 1, all right? In other words, it just goes 5, 5, 5. I'm multiplying by 1, multiplying by 1. Suppose I added this to 10 terms. I don't need a formula for that, all right? The answer would just be 50, all right, if I added it to 10 terms. Okay, so this formula gets provided in tests and exams, right? And it enables us to find the sum of a geometric sequence. If we had subtracted these two rows the other way around, we would have got a different version of this formula. All right, and it also doesn't apply when R is equal to 1, so this is R not equal to 1. What we've actually done is just switched both the minus signs around. Okay, in other words, we've subtracted them the other way around. Okay, we don't need to know the formula for the sum of a quadratic series. Let's now practice using our new formulae, all right? And we're not going to, it's really important, we're not going to tell you what we're dealing with. So the first thing we're going to decide is what type of sequence is this? Is this arithmetic or is it geometric? We've got these two formulae. This one, in fact, is arithmetic. So the formula that I'm going to use is my formula for the sum of n terms of an arithmetic sequence. N over 2, 2 lots of A plus n minus 1 lots of D. All right, and so sum of 28 terms is actually going to be 28 over 2, 2 lots of A plus 27 lots of D. And D is any term minus the term before it. It's actually 27 times 4. When I put all of that into a calculator, I get the following. Let's just see what it is. It's actually 1,568. Okay. Right, let's look at another one. This one. This one is not arithmetic. This one is, in fact, geometric. Remember, R is found by dividing any term by the term before it. When we divide 100 by 1,000, we get 1/10. When we divide 10 by 100, we get 1/10. This one has a common ratio, not a common difference. This is a geometric series. Now, remember our formula. It looks like this. A, 1 minus R to the n, 1 minus R. I want to add up 6 terms. A is 1,000. So it's going to be 1 minus a tenth to the 6 over 1 minus a tenth. Right, again, I can put all of that into my calculator and I can get a final answer, which happens to be 1,111,11. Right, let's look at the next one. Arithmetic or geometric? Well, we're not adding a fixed amount. In fact, we are multiplying by a fixed amount. This has a common ratio of -2. Any term divided by the term before it. For example, 16 divided by -8, -2. Our formula, Sn, A, 1 minus R to the n over 1 minus R. So the sum of 12 terms is going to be A, which is 1 minus, now just be careful here, let's just put some brackets in. R is -2 to the power of 12 over 1 minus -2. Right, providing I type all of that neatly and exactly like that into my calculator, I get my final answer, -1,365. Okay, the next one. What is it? All right. Well, in fact, it's an arithmetic sequence. I don't know how many terms there are here, right? But actually, if I look at it, these are the multiples of 2, and 10,000 is the 5,000th multiple of 2. In other words, this is the 5,000th term. In other words, I've got 5,000 terms, right? If I didn't know that, I could work it out using my TN formula, but I can save myself some time if I realize that there are 5,000 terms. This is arithmetic, so I'm going to be using this formula. Could use the sort of variation of it where I use the first and last term, but let's not do that right now, right? So the sum of 5,000 will in fact be, 5,000 will in fact be 5,000 over 2. 2 lots of A is 2, plus 4,999 lots of D. And D is in fact also 2. D is any term minus the term before it. If I put all of that into a calculator, I get 25 million and 5,000. Okay. Right. One last trick that we're going to show you regarding sums. All right. Sometimes an examiner will try and trick us by giving us a question, giving us an expression for the answer for a sum. So they don't tell us anything about the sequence. They just tell us that the sum, all right, of some terms is given by this expression. And then they ask us, what is the fourth term? Right. Now, there's a clever little idea here. If we worked out S4, in other words, we put 4 into this equation, we're going to get 4 cubed plus 4 minus 2. We actually get 66. If we put S3, we work out S3 by putting 3 into this equation. 3 cubed plus 3 minus 2 equals 28. Now, if we think about S4, S4 is actually term 1 plus term 2 plus term 3 plus term 4. Right? S3 is term 1 plus term 2 plus term 3. Now, if we look at this, the only number that is in S4 that's not in S3 is T4. And so, in fact, T4, the term we've been asked for, is actually just going to be the sum of 4 terms. That's the sum of the first 4 terms minus the sum of the first 3 terms. All right. And we get 66 minus 28, and we get 38. Quite straightforward when you've seen it. If you haven't seen it, it's a useful trick to have been exposed to. Okay, and I think that brings us to the end of today's lesson.